Hello and welcome to the third video of our series on infranoise or infrasound. And now we would like to show our own measurement results we have done with our measurement device that we have bought for a lot of money, that we also see here in the slide. And with the help of our student Jakob Palm, we did some measurements on a wind turbine, and we sent him out to find a single wind turbine that is hopefully far away from other infrasound sources like large streets with a lot of traffic noise or industry, so that we only have really the natural infrasound emissions from the wind itself and the wind turbine. And then the measurements he did it according to the European norm, and that says that we need to measure in a distance from the wind turbine that is the same like the hub height of the wind turbine. And that also in the direction of wind, so that at the place of the wind measurement device, the pressure level is the highest one. And we also always need to say that in this case, it's 230 meters away because the turbine is 230 meters high. That is much closer than ever people are living at the distance. So in real life, quite often the distance is a kilometer or even more. And Hannah, what results of these measurements?
Yes, so in this graph you can see the measurement results, namely the third octave level. And the blue solid graph shows the sound pressure level at a wind speed of 6.7 meters per second, and the orange dashed line at a wind speed of less than 1.4 meters per second, thus with almost no wind. And both levels are in the infrasound range below the perception threshold, which is indicated by the gray dotted line. And the results of the other measurements are shown here. So at the top left is a measurement on a road drawn in blue when there are no cars, and dashed in orange when 3,300 cars are driving per hour. So the infrasound level on the busy road is roughly the same as the level of the wind turbine at a distance of 230 meters. In the graphics at the bottom left and bottom right, it can be seen that a washing machine in the spin cycle also emits infrasound, and as does a refrigerator, but the level from the refrigerator when it is switched on is of a similar order of magnitude as when the refrigerator is switched off. So the infrasound was measured in a car at the top right, while driving at a speed of 130 kilometers per hour. So the blue solid line shows the results when the window is open, and the orange dashed line when the window is closed. And both levels are above the measured values of the wind turbine, and at a frequency of approximately 16 Hertz, the level is even above the perception threshold.
I could not resist plotting those curves also on my preferred linear scale, expressing the pressure level in Pascal. And what we see here on the first is once more, in my case it's the blue line, that is the perception threshold. And then in the green we have the noise without the wind turbine in operation, so when it's more or less a calm. And on the next one we see then this wind turbine in operation, but together also with the pressure level of the wind itself at a wind speed of 6.7 meters per second. And we see it is far away from this perception threshold. And when we now add also the other measurements, we see here, for example, the washing machine. And at least we can see it's close to be on the level of the wind turbine, but at a frequency of 10 Hertz, it is significantly above. When we also have a look to the traffic, then we see it is close to what is with the wind turbine. But what is really exciting is when we are not watching the traffic from outside, but when we sit inside the cars at the motorway. And there we have this bright yellow line that at least at a frequency of 20 Hertz with the open window has an enormous sound pressure level. And that I think most of us have experienced when we drive quite fast with an open window, that we almost can feel these pressure levels in the car. But even more interesting, I think the dark yellow line, and that is when the window is closed. And there we see that the pressure of infrasound is much, much higher than that of a wind turbine.
Yes, so in order to check our measurements for plausibility, we compared them with the measurements of the LUBW. And in addition to the measurements on wind turbines, they also carried out measurements in the interior of a car and on a busy road. Mm-hmm. And their measurements too, the sound pressure level in the interior of the car is highest and in some cases above the threshold of perception. And our measurements on the wind turbine are in a similar size range as the measurements of the LUBW, so which makes it clear that our measurements are comparable to those in literature.
When I conclude for that time, I'm quite happy that the infrasound emissions from wind turbines are for good luck lower than many others we have around our daily life. But nevertheless, in the next video now we would like to have a look on what do we know, what infrasound could cause on the health of humans. So that will be the next video. Thank you very much.